So this section is 4.1, but we're doing example 4, where we are graphing the reciprocal function. So how do you graph a reciprocal function like y equal to 1 over x? So let's go ahead and do that. Let's go to the setup here. So if you're going to do this on your calculator, you just go ahead and turn it on, hit clear. You go to the y equals, okay, and here you would type in 1 divided by x, okay, and then I would suggest that you do a zoom 6, and from there you can see the picture. I actually downloaded this off the internet. It's called Wobbit EMU, so this is something I got for free, so if you're interested you can research that and do that. I don't have any directions on how to do that. Or you could just download an app to your phone so that you have a TI on your phone as well. That's what I would suggest. Or you're just going to have to graph everything on paper anyways, so that would be something you'll have to do anyway. So let's take a look at how you would do that on paper. Let's say you have graph paper. I don't have graph paper here, but if you have graph paper, that's probably better. So here's my graph, and I'm doing y equal to 1 over x. If I made a table, I would start off with a table, so I would use some negative numbers as well as positive numbers. So probably would do something like -10. Go down to maybe go to -5. Let's say -1, 0, and then go again with 1, 5, and 10. And so then I'll put them into the equation. So this would be 1 over -10. Okay, so you could do that as a decimal if you want. So you could write that down as the same as -0.1. So this is -0.1. Then we could do the next number, which is y over 1 over -5. So that's negative, and that's probably around 0.2. Okay, so this is -0.2. And then we do y over 1 -1, so that's just -1. This is 0, and everything is just flipped. So then we have 0.2 and then 0.1. So if I go to graph this, go out to 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so it's just slightly below that, so it's just really close. Okay, and then I do -5, 1, 2, 3, 4, 5, and it's 0.2, so it's a little bit higher. Okay, and if I say this is about 1, -1, then I could go over 1, down 1. Okay, and then it also gets bigger on the next one. So we go to the next one, which is 0, 0. No, this is not 0, 0, because y equal to 1 over 0 is undefined. So it's undefined, so cannot plot this point. Then we have 1, 1. Okay, so here's 1, 1. So something like over 1, up 1. Okay, and then let's say we go to 5. So it's 1, 2, 3, 4, 5. It's at 0.2, so it's coming down. And then at 10, so 6, 7, 8, 9, 10. It's really close. I still can't see this picture. It kind of looks weird. It looks like it goes to here and it stops. So let's do a couple more. Let's say I did something like negative 1/10. Okay, if I did negative 1/10 in for x, then it's going to look something like this when I put it into the equation. It's going to be y equal to 1 over negative 1/10. And so if I put that into the calculator, it would see that it's going to be a large number. Okay, so that would give me negative 10. So this right here gives me negative 10. So that's nice. As I get really super close, it gets plotted down here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as I get closer to 0, it gets super high. So this is much better. I can see now what's going on. So the curve's going like this, and then it turns and goes like that, and this point is on that curve. And the same thing for here. This would be 10 up here as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So something like here. So coming down and curving. Okay. And so there's the graph of what you do. And so it's nice to have graph paper, but I don't have graph paper on my smooth draw. So please do the best you can on plotting as many points as possible so that you get a decent curve. So this is pretty much matching to my graph that I see here, because 1 divided by x gives me this type of curve. So one of the questions that we like to know is what is the domain and the range. So my domain, okay, is all the x values. So is there any x value that, because I see that it goes all the way to negative infinity, and it can go all the way to positive infinity. So it looks like I'm using all these numbers, but there's one number that I cannot use, and that's x at 0. So it would be all the real except 0. So we could just say x not equal to 0 for the domain, for that basic. So now we look at the range. Range is all of the y values, right? So as we look at that, we have the same situation. We have all the reals except y can't be 0. So that's the only thing we can't have. So the domain and range is pretty much standard like this. Okay. So then, now the next thing we want to talk about that's new is called an asymptote. So let's put that down here. So an asymptote. Okay, so an asymptote basically is a line, okay, that a graph approaches, okay, and it's a guide the end behavior, such as negative infinity and positive infinity of the function. Okay, so the asymptote basically is a line that the curve is getting closer and closer to, but is not going to cross it. And you can see that in this picture here, better in the graph. So if you look at the graph, you can see how this curve gets closer and closer to the x-axis, but if we keep zooming in on this area, it never will cross the x-axis. Same thing here, it won't cross the y-axis as well. Okay, it won't cross the y here, and it won't cross the x here. So we have two asymptotes. So we have an asymptote at x equal to 0, and we have an asymptote at y equal to 0. So x equal to 0 means that if we're at the origin, x is 0, but then y can be anything. So that's this y-axis. So x equal to 0 is the y-axis. Okay? And so this is a vertical asymptote. And this y equal to 0, that means at the origin y is 0, but x can be anything it wants to be. So that's the x-axis. So when you see the asymptote of y equal to 0, that is the x-axis. And so this is called a horizontal asymptote. Okay. So again, we know we have a vertical asymptote at x equals to 0 with this one. Okay, and then we have y equal to 0 for the horizontal asymptote. And so what I'd like you to do now is do the triad. This is another problem like this, but in the triad you're going to do a different equation. So here's the triad. So do y equal to 10 over x. Make a table and make a graph, okay, best you can. And then when you're done, tell me what the domain is. What is the range? What are the asymptotes? Okay. Where are the asymptotes in the equation? Can you write the equation like we did for the asymptotes here? X equals 0, y equal to 0. And then once you're done, take a picture and email that to me. Okay, thank you.